Assalamualaikum and a very good morning to all. My name is Nizamuddin Yusuf, the moderator for today's webinar. I am from the Assistant Vice Chancellor Office, Industry and Community Network, University Technical Malaysia, Melaka. For your information, this webinar series is under the umbrella of Knowledge Transfer Program, KTP. It is one of the methods from the Ministry of Higher Education to transfer knowledge from the university to the industry. Our topic today is data generation, IR 4.0, connecting machine via open source software by using simple hardware as gateway. And this topic will be delivered by technologist Khairul Anwar bin Iraman. Technologist Khairul Anwar has more than 24 years of experience in electronic field. He is currently responsible as senior teaching engineer in UTEM and has sharing experience, knowledge, and technical know-how. He contributed in producing new engineers and technologies, as well as conducting new research and development projects through numerous funding from inside and outside the institution. Apart from giving lectures, tutorial, and facilitate experiment session, he has coached and mentored more than 30 talented future engineers for their final projects and innovation projects. Without further ado, I would like to invite technologist Khairul Anwar bin Iraman to deliver his speech. Mr. Khairul, the floor is yours.
Okay, Assalamualaikum and a very good morning to all. First of all, I'd like to thank Dr. Nizamuddin for inviting me as speaker for today. And thank you to all who would like to listen to my sharing session today. So the topic of my talk today is data generation. Actually, it's about IR 4.0, where currently the government already introduced this, so I would like to share with you all about this data generation. So let's look at my slide first of all. Yeah. Can anybody see this?
Yes, we can see it.
Okay, this is my topic for today. It's data generation. But firstly, I would like to share with you all about the what is industrial revolution actually. Yeah. So industrial revolution started in the early 18th century, about 1784, where steam power was introduced in England. So during that time, the manufacturing production, they used this as the first step of industry. So the second step of industrial revolution is Industry 2.0 at 1870, where in Europe they started mass production, started assembly line. They started using electrical energy. And in 1969, they call it Industrial 3.0, where they use automation, they use computers and electronics devices to run the production, mass production and everything. So as of today, Industrial 4.0 was introduced, where they use IoT, Internet of Things, and to connect machine to machine, and machine to server, server to server. So for this topic, I would like to share with you guys a low-cost IoT structure that we can use in the industry. Okay. So what I said just now, this is about IR 4.0. So if you see this graphic, where all things are shared through the internet. So we have augmented reality, big data, 3D, cloud computing, system integration, cybersecurity, simulation, Internet of Things, all together. and it is called IR 4.0. So the communication protocol is one of the most important thing, where they communicate device to device, device to server, and server to server, as I talked just now. Okay, before I continue, I would like to share with you. Before we start this, IoT gateway speech, I would like to share with you why we need this. And let's say we need all data in our manufacturing process. We have a lot of data here. So how we going to extract these data to be used in our daily manufacturing works? Okay. So data such as temperatures, pressure, all that needs to be extract from our production and do some analysis and to do improvements. Therefore, we use all our, manual, yeah. Until now, they just use it manually, and so this will take time. So that's why we need something like automation or real-time data, so that we don't need to use all this manual calculating, manual analyzing. Yeah. So I give to you the briefing introduction about IoT gateway. Okay. This IoT architecture is divided into 3 domains actually. Yeah. We have sensing domain, network domain, application domain. This domain sensing plays an important role in IoT, enabling interaction and communication between the machine to machine, to network infrastructures built. But however, they collect information from physical target using technologies such as wireless sensors, WSN, RFID, etc. So the network domain is focused on current or emerging communication, such as PSTN, 2G, 3G, LTE. And then currently the fast go all around is about 5G. Although Malaysia hasn't started yet, if you can see in China, they already started 5G, right? They can move trucks, big trucks automatically. So that's why in Malaysia right now they are going to introduce this sooner or later. Okay. So the goal is to move the collected data from sensing domain to remote destination. So how we going to connect this data, and then go through the internet, and then go to everybody else? Okay. So data can transmit with layer managed by application domain to the respective management system, which specific service are offered to all types of users. Means that everybody can see this. So I can see this from my home. I can see this, and everybody can see this on the production floor, right? So if you can see the structure here, so we have gateway, we have network and cloud, and then it will connect together, extracting data from various machines, right, through the gateway, and then to dashboards. I mean, to your computer dashboards, to your applications in your cell phones. Okay. So to connect this, we need new technologies such as not new now lah. Actually, Zigbee, Bluetooth, Wi-Fi, and the network area controller wherever you are. So from the manufacturing point of view, it is a stationary platform where we only need to use the Wi-Fi network in that area so that all the machines can be connected. Okay. So how to connect this? We need hardware and also software, right? So before I start this explanation about the software and hardware, I like to share with you a video.
Is the video content sound?
No, it's a video content. It's YouTube.
YouTube.
Yeah.
Maybe you up there is automatically optimized. Maybe you can switch on the sound there. If not, there is no sound later. There is a speaker on the right side. On the automatically optimized, and there
Yeah.
is a yeah, the
Okay.
symbol there. Yeah, just click that one. Okay, and then you can select the video.
Yeah.
I think just share the screen because it's from the YouTube, right?
Yeah. Yeah.
I think just click the share and then you can go to the website.
Okay. Can you see this?
Yes, we can see it.
Okay. Okay, these are the work from my students, which they use what I said about just now. Is the
This is my project demonstration video. My title of the project is Development of Android Application for Monitoring the Manufacturing Process, and my supervisor is Encik Khairul Anwar. So here we can see the Node-RED dashboard and the Mpqtt dashboard. So I've given the input from the mobile application to the machine. So the machine start working and the green light of the tower light is turned on. And this also has been notified to the Node-RED and Mpqtt dashboard. The color of the green light has been turned on in Mpqtt dashboard and the Node-RED dashboard. When the machine placed the metal product to the conveyor, the timer turned on. So we can see at the Node-RED dashboard, the timer has been turned on. And when the metal product tapped to the second time sensor, the timer is off and it is shown 4 seconds for the time taken for the product to move along the conveyor. The machine is now going to place the plastic product to the conveyor. So when the plastic product is placed on the conveyor won't move. So it indicates the yellow light on the tower light of the machine, and this also can be seen on the Node-RED dashboard and Mpqtt dashboard. So when yellow light is turned on the tower light, so a technician or engineer is able to know that is the non-metal product is being detected and need to be placed in the non-metal product box. After the non-metal product has been placed to the non-metal box, the machine will continue its progress. So the green light will turn on and we can see the green light also has been turned on the machine, on the Mpqtt dashboard and the Node-RED dashboard. So as we can see, there is no product being placed on the conveyor. If there is no product detected on the conveyor, so the machine will back to the home position and the red light will turn on, and this also can be seen on the Mpqtt dashboard and Node-RED dashboard. Okay, now we see the nearer view of this project demonstration. So we have give the input to the machine and the green light turn on. This can be seen in the Node-RED dashboard and the Mpqtt dashboard. So the machine going to place the metal product on the conveyor. The first sensor tap the metal product and the conveyor moves, and the second sensor tap the product and the conveyor stops.
Okay, ladies and gents, these are the very simplest way that we connect machines through through Raspberry Pi 4.0. Yeah, Raspberry Pi 4.0, which connect to the sensors in the input and output I/O port, and then connect it to the this is called Node-RED dashboard, and connected via Wi-Fi to the cell phone. Yeah, and an application in cell phone, Mpqtt application. So the software that we are using is called Node-RED. So it is actually an open software. So we can find it, you can download it on the internet. Yeah. But we still need to learn how to program. Right. So these, I mean, these students, they learn it, how to program it and how to connect all the hardwares and also the softwares, so that they can extract the data. So it's not just this data. This is very simple data, such as time, time taken for the robot arm to put the metal the metal component to the conveyor, and the time the conveyor start to move until it stops. So they're collecting these data, but these data, they collect it real time. Yeah. So these data will automatically captured by the software inside the computer. Yeah. So we can, I mean, real time extract the data. We can also real timely see the graph. Yeah. From this what you call dashboard. Yeah? But this dashboard only shows the working of the machines connected, which is red stop. For yellow is ready to stop, and then green for moving. In this dashboard also, there is a start and stop button. So we can use our dashboard to start and stop the machine itself. So it is also the same application also goes to these apps. So we can see the red button, yellow button, and green button. And also we have a stop and start button in the application. So we can remotely start the machine and remotely stop the machine. Okay. So what important I want to say here is what type of data that we need, right? So the type of data that we need, we have to firstly list down all the data that we need, and then from there, which sensor we choose, which can be used to tap this data, and we tap it, and then connect it to the in my experiment. I'm using Raspberry Pi 4.0 and Raspberry Pi 4. So we put it, I mean, we connect it to the Raspberry Pi, and then the program will, the program will interface, and then collect those data that we need, and make it what we call database, database for analyzing. So it is up to the users and the end users which data they need, and when they need it, because this Node-RED software is it's a time based. I mean, actually it is a what in the software language called timestamp. Yeah, time stamping, where every microsecond will count and validate all this data. So the data will come out real time, and all your supposed to be analyzed data can be captured in real time. Okay. So I will continue this. If there's any question, you can just ask. Yeah.
Okay, now the robot going to place the plastic product, which is non-metal product, to the conveyor, and we can notice the conveyor won't move because that is a non-metal product. It is not suitable for the next production process. So the robot need to eliminate or remove the non-metal product to the non-metal box. And this indicates the yellow light, and we can see in the Node rate dashboard and Mpqtt dashboard. So after it has been removed to the non-metal box, so the machine will start to operate back as normal, and the green light will turn on, and this also can be seen in the Mpqtt dashboard and Node rate dashboard. So here we can see there is no product has been picking up by the robot. So there is no product has been placed on the conveyor. So the robot will back to the home position and the red light will turn on. So this also can be seen on the Mpqtt dashboard and Mpqtt application. So the data that has been taken from the conveyor will be stored in the Raspberry Pi Excel document. So which we can see the data has been stored in the Excel document in the Raspberry Pi. So this can be used for the further analysis. My project was also involved in Digital Innovative Museum UTEM exhibition.
Okay. That's it for the video. So, unshare this. Okay. Let me continue with the. Okay, as we see in the video just now, so we have network and cloud where all the data are supposed to be in, and then the gateway, and then the things that we see in the screen and also the applications. Okay, so this is the block diagram on how these things are connected. So if you can see, firstly, we need to have a Wi-Fi network, yeah, which is connected to the LAN and modem. So firstly, we have a web browser that we use as a broker. Broker means that all things, I mean, all the signals will be catched into this broker and then sent to the web browser and also the application. So from the machine, we have a PLC. Yeah. So in this PLC, all the sensor wires and everything are put, are connect together with the machine. So we tap from here. We tap the machine. We tap the wires to the IoT gateway. This IoT gateway. And then this signal from the IoT gateway will go to the broker, Mpqtt broker at the left bottom, and then will be transmitted to the party web browser and also to the handphone application. So it is quite a simple task, but for example, if we need to use in a heavy industries, we need to have a better IoT gateway. For example, my project here in UTM, we are using Raspberry Pi. So it is not very suitable for heavy industries such as industries are using high temperature and very dusty area. So we need to have to use another IoT gateway, which is here we call it a Siemens IoT gateway. So this one is very compatible for heavy industries. So is there any question?
So far, there is no question in the chat, but if anyone have a
If
question, you
anyone have
can
any
just unmute
question,
yourself and can ask directly to the speaker.
so I continue with my presentation. So what you see in the screen right now is a block diagram for the Mpqtt architecture. So this block diagram on how the data and work are integrated together with hardware components and software applications. Yeah. The Mpqtt broker and Node-RED will integrate. The Wi-Fi module will be the platform to convey all the data from the router to the smartphone apps and the computer screen. Okay. So what is Node-RED actually? Node-RED is an open source programming, which is we can download for free, because it's open source in the internet. So if you Google it, Node-RED, and then you can easily download it from the internet. So I'm not going to, go into details on how to program, because that one will take 6 days, minimum 6 days to do the explanation and then training to use Node-RED. Yeah. So the method is very simple. So inside the program, we need to firstly visualize which data that we need. So Node-RED is a kind of it's not like Python. It's easier than that. It has the what do we call that, payload, and then send the payload as the message to the broker, and then the broker will what do you call that, will encrypt the message and then show it as a dashboard, dashboard on the computer screen and also in the apps. So how other people can see this? So in the dashboard in the computer screen, it's a web browser, right? So we can use the address of the web browser, and we send it to the people who wants to see it outside of our working area, because the what do you call that, the process of the internet works only in the same network. It cannot go out, right? So if other people want to see it, you need to use the address, the same address of the web browser, and also we can use it. We can use a QR code or tiny URL. The address is so long, so we need to shorten it. So we use tiny URL and send that address to the people who wants to see the data, right? Outside of the network that they use inside the factory lah. So firstly, what a production floor need to have is a stable network, right? So if we don't have a stable network, always, you know, sometimes it's okay, sometimes it's not. So this thing would going to be in a good condition. So we need firstly a stable network, the same network for all, and then we need to have a node rate. We need to have at least one IoT gateway and one broker. A broker is like all the programming inside that broker to initialize the process. Yeah, the program is put inside this broker, so this broker will be the server lah. I call it simple name is a server. We need one server, and then we need an IoT gateway to transmit, and the apps for monitoring. Okay, and the apps is not just used for monitoring; it can also use for controlling the production. We can stop or start the machine as needed. Yeah. So,
Okay. Mr. Hero, sorry to interrupt you.
Yeah.
Actually, there is one question from the floor.
Yeah.
Can you give some advice on how to start learning IoT for beginners?
Okay. So,
Any advice to start the IoT for beginners?
okay. It's like this. IoT, actually, we need to understand what IoT first is. Yeah, Internet of Things. Yeah, where everything connects. So, if we want to learn it ourselves, I think you can join. We have a sharing session in time where we can share the how IoT works. So you can also use YouTube, because a lot of in YouTube that is very good to learn. Yeah, but for beginners, yeah, I think we need to read first lah. Few study. You need to study first, and then what type of system, firstly, that you want to use in IoT. Yeah. So and then we can go through some courses. They also have some explanation, a good explanation in YouTube. Yeah, you can learn everywhere actually. In these days lah, everything you can learn in YouTube. There's one question from Rushilawati Sulaiman, is it? Okay, the program language. Actually, it is a simple, just a language used by Node-RED. It is not Python, but Python is used by what do you call that? Another hardware. But for Raspberry Pi, for this one, actually Raspberry Pi already include Node-RED inside it. Yeah. So you only have to the program to program it. We only use buttons. You see. there are buttons that are like Visual Basic, right? Like Visual Basic, you have buttons, right? So you just drag in the buttons from the library and just choose that. Yeah, it's very simple. So if I can show you something, yeah, hold on, yeah. Hold on. I show you Node-RED lah. Mati ni. What's the problem? If you hold on a second, yeah. I think I have my Node-RED inside here.
Right now, we didn't see anything. It's just
Okay. Yeah.
black.
Hold on.
Okay.
I'm trying to find it. So I share this, yeah, with you.
Configured your Groove IO nodes, you may want to start doing something more interesting
So you
with
see can you see the screen right now?
Yes, we can see.
Okay. You can see the screen. All of this is buttons that we can just drag into the sheet. The sheet where the flow where you said flow on how to make a program. Yeah. The plan. Yeah. Okay. Hold on.
your data. If you haven't already installed these nodes and configured your device, go ahead and watch our previous video that goes over that process. In this video, I'll be downloading some new nodes to create a simple UI dashboard within Node-RED that I can use to access and control my device. Now, before I dive into going ahead and using these Groove nodes, I'll first need to do some other setup. And specifically, I'll need to come up to the Manage palette and install my new nodes, since you'll notice that there's no dashboard or UI nodes here. I do have all the core nodes that come pre-installed with Node-RED, and the Groove IO nodes that I'll need to communicate with my Groove Rio that I'm using for this demo. Before I can come up to this install tab and search for nodes, I will need to have a gateway to the internet. But since my Rio here is connected to my home router over Ethernet, I can go ahead and type in here dashboard. Now, it's really important that you select the correct result for dashboard. You want this Node-RED dashboard, not this CN dashboard nodes. So it's Node-RED dashboards, this set of dashboard nodes for Node-RED, and you'll always get the latest version. In this case, we're using...
Okay. It is as simple as I said just to you. So the first thing that we need to have is the same network. Yeah. The same network that we can connect the Node-RED to the MQTT, to the broker, and then to the dashboard. So what this guy is going to show is on how to the dashboard is being used. So it is very simple. You just pick in the library and then put it in the worksheet, and then join it together with we call it a string, like a process flow. Yeah, I'll show you.
Using 2.27.0. My return code of 0, 4.2 gallons, but device, and I want to get done so I get really good resolution in Node-RED. I'll give this node a name like read fuel level, and click done. That's all I need to do for that part of the groove. Now I want to decide how to display this. I could simply pick a text field that will show the numerical value of my fuel level, but instead I'm going to create a gauge. So I'll just drag that in and double click it to configure it. We can see here that I need to configure a group. That red outline there means this is misconfigured. Since you don't have any groups by default, just select the...
So this guy is going to measure fuel level, right? So firstly, the rate fuel level here, just change the name from the block there, change the name to the fuel level, and then put one gauge. Yeah. One gauge, so that the fuel level will connect to the gauge, and then the gauge will transfer. I mean, to it's not transfer, it's you call it read the fuel level, and then show it to the dashboard what is the level of the fuel. For example, 2 liters, 3 liters, and so on. So that one we can configure in this program.
Pencil icon to add a new one. Once you create that group, you'll notice that again you have to go a level deeper and create a tab to hold that group. I'll again click the pencil icon, and we can see here this is where I get to create my tab. I'm going to simply leave this at the default name home, and the dashboard icon is just fine. But you should note that you can use different types of icon packs like...
Okay, so that is, I don't want to go into deep into this because that is not the platform for today. So, so that is how we program the things that we need from the machines, the data that we need. Just now, the guy shows that he needs the data for the fuel level, and then how can the program interpret this, right? How can this fuel level be seen in the dashboard as numbers, right? So he put it another block, gauge. I mean, the gauge is used to measure the fuel level. Okay. Then the program will transfer the fuel level magnitude. I mean the quantity, the quantity through the broker and then to the dashboard. So the dashboard will show or will show the actual quantity of the fuel. Okay. Okay, that's another question from Alia Azlan. Is there any feasibility to integrate the database with other program tools such as Python so that further analysis can be done, such as downtime prediction? Okay, that's a good question. So actually, yes. Even if you use this Node-RED and minimally a Arduino, we can use Arduino also. We can use that's for minimum, and then we can use like my students use Raspberry Pi. So the tools inside is already in Raspberry Pi. There's already Node-RED inside it, so it is very simple to program. So from that, we just don't. We not just can analyze real time, but from that data, we can see trends, right? We can see the trends of the data. So we can put, for example, limit for the data, upper limit and lower limit. So with that, we can use it for the downtime prediction. Does that answer my question? Your question? From this data, we can actually, yes, we can predict downtime. We just put it upper limit and lower limit in the program, and then when the machine stops, it will trigger, right? And when the machine starts again, it will trigger you also. So we can see from the stopping time and starting time, that is the downtime lah. We can really measure because Node-RED is a timestamp program. Means that it will give you data in real time in microseconds. So we don't have to, go down there and calculate manually the downtime.
All right. Is there any question? So, Mr. Khairul, maybe you can continue with the
Okay.
presentation, or it's already finished?
No. I still have a few.
Okay, you can continue.
Yeah.
Meanwhile, for the time being, in the chat I already put the link for the attendance and feedback form. So maybe you can fill up the form to get the certificate of participant digital in digital, and also for CPD point for UTM staff. Okay, Mr. Harold.
Okay. Okay. These are the oh, you cannot see. Hold on, yeah. Share lagi. Okay. This is what a Node-RED programming looks like. Yeah. So you can see there's a start button here. Can you see that? Start button. And then select. And then message payload. Yeah. So all this we connect together. See, change. We the select here. We put change email. We put email email address inside there, and then put that BAPL user change, and then send the message here, and then this message will directly go to the broker and then to the dashboard. Yeah. Even if we're going to, let's say, the machine stops, and then we can program this node rate so that your bosses, I mean, let's say you are an engineer, right, in the field where the machines stop, but it is at night. So this program can automatically send message, whether it is telegram message or emails, and then allowing the your bosses lah to see whether the problem is treated or not. Yeah, because the machine stops, and then it stops, and you put the time of the machine stops, right? And after the machine is maintained or being repaired, after the repair, the machine, I mean the program will again initiate a notification to the bosses saying that the machine is now running. Yeah. So you see, it's a very simple task, and I mean, I think Infineon already have this since long time before we starting IR 4.0, I think, because I was in Infineon from 2004 to 2006, end of 2006. So it has already start IR 4.0 already. But they're using not the same program lah. They're using Siemens, so it's a very expensive program and very expensive way for, I mean, if you are an SME or something like that lah. Okay. So any question? Do you understand what I'm talking about this? And all these are the on the left side. The left side is the button that we can use to put it into the flow, to the flow of the program. Any question?
Maybe there is one question from me.
Okay.
How about the security in the IoT, such as the privacy of the data and so on? How can we overcome this kind of challenge?
That's a good question. Because right now, the network itself, like I said just now, the first in my first opening, where I said the internal network. So, for example, if in UTM we are using UTM network, right? Right. So it is up to the so-called jabatan or departments which using that particular network to have the security. Right. So if it is not the security is not good enough, then anyone can penetrate. So it's belong to the where you work in lah, the department lah. Right?
All right, thank you.
Any more questions? Sorry, I'm not. My English is not very good lah.
I think there is no more question from the floor. Okay.
So if you guys need more information, you can just drop down an email so I can answer. And also, if you need any advice on how to use this, so you can also contact me.
If all doesn't have the contact number or anything, you can directly email me, and I will directly the email to the Mr. Khairul. Okay. So that's it, right, Mr. Khairul?
Yeah, that's it.
Okay, thank you very much, Mr. Hairul, for an informative presentation. We'll need to share back my slide. Okay, so this is actually the QR code for the attendance and feedback form. I already put the link in the chat box. So for those who still didn't do the registration, maybe you can take some time and fill up the form, and you will get the digital certificate of participation and also the CPD point for UTM staff. Meanwhile, this is our social media. We have a Facebook and also LinkedIn. So basically, for any of the activity or webinar like this, we will advertise or put it in our social media. And for your information, this afternoon at 3 p.m., we have another topic, which is a reverse engineering service for marine industrial, will be delivered by Mr. Muhammad Rafi bin Omar. I hope for those who have time can join this webinar. And before we end our session for today, I hope everybody can switch on their camera so I can take a screenshot, and this will be our memory later. Okay? Okay. So please smile. Yeah. Say cheese. 1, 2, 3.
Yes.
Okay, that's it. Thank you so much for joining our webinar. We have a lot of webinar, basically around 30 or 40 webinar for this year only. I hope we can see you guys again for the next webinar.
Yeah.
Yeah. And till next time, Thank you so much and enjoy the rest of the day. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi